this video, I would like to tell about the optimizing survival analysis of XGBoost for ties to predict disease progression of breast cancer. Then we are going to see about the overview of our process. Here, machine learning is frequently used in medical application such as detection of the type of cancerous cells. Here we are predict the diseases breast cancer. Breast cancer is a type of cancer that occurs mostly in females and the leading cause of women's death. We are implementing the survival analysis based on multiple factors, mainly focuses on estimating the survival probability of a particular time of interest for a patient. Under survival analysis, we are implementing the Cox proportional hazard model. Is basically a regression model. It is generally used by medical researchers to find out the relationship between the survival time of a subject and one or more predictor variables. In our process, we have to take the input as survival breast cancer dataset from the dataset repository. By using XGBoost, we have to find the AU score of overall prediction. Then we have to find the mean value, median, standard values, and also visualization. Here we are visualize the survival analysis of our input dataset. In our process, the main objective is to analyze the survival by using the proportional hazard model. Under proportional hazard model, we are using Cox proportional hazard model or using the survival analysis. Then to predict the disease of breast cancer by using the machine learning algorithm, that is boosting algorithm, XGBoost algorithm. Finally, to find out the most appropriate method that will support the large data set with good performance of predictions and also to enhance the overall performance. Then we are going to see about the flow of our process. First we have to take the data set survival breast cancer. Then we have to take the input data from this data set. After that we have to implement the pre-processing step. In this step we have to remove the unwanted noise or unnecessary data from our input. In this step we have to check the missing values. Why this is used means we have to avoid wrong prediction. If is there any missing values is present in our input data, we have to replace that missing values by zeros or non-values. After that we have to implement the survival analysis by using proportional hazard model. In this step we have to implement Cox proportional hazard models. It is a regression model, the relationship between survival time and predictor values. By using Cox proportional hazard model, we have to find the Cox regression values, because I already said this is a regression type. Okay, so we have to find Cox regression value and also we have to visualize the survival analysis of overall our data set. Then we have to implement the data splitting. It is the act for partitioning our input data. That means we have to split the data into test and train. Test contains the small portion of our input data, train contains the most of our input data. So after that we have to implement the classification algorithm. Under classification we have to implement XGBoost algorithm. By using this algorithm we have to find some performance metrics like AU score, that is accuracy value, overall prediction. Then we have to find mean value, standard value, and visualization. What the and some of the visualization. Okay, this is the flow of our process. Now we are going to see the our output part, that is demo. We are going to see run our process in Spider IDE from Anaconda Navigator. Okay, our process is successfully run. Just I explained one by one. Yeah, this is our output part. First we have to select our data. So this is our input data. Just I have displayed some sample of input data from our data set. So our data set contains age, year, note and status. The status contains the value 1 and 2. This means 1 is for survival and 2 means for death. After occurring the cancer, the 1 represent the patient will survival, the 2 represent the death. After that we have to implement the pre-processing step. I already set in a flow diagram. So this is for checking missing values for each attributes. This is our column name from our input data. Here display the value 0. The 0 means there is no missing values in age attribute column. So similarly, so there is no missing values in our data set. If it is present, we have to replace the missing values by zeros or non-values. After that we have to organize our data by using the survival analysis model, that is proportional hazard models. So here we are predicting the death value. That means 0 means there is a no death, 1 represent it is a death. Okay, so just we have to organize the data. After that we have to predict the event table by using the Kaplan-Meier filter under the survival analysis. In this step we have to predict the removed and observed and risk score are calculated. After that we have to estimate the in the form of visualization. Finally we have to analyze the survival of our overall data set. Then we have to implement the SGBoost algorithm. Under the SGBoost algorithm we have to find some performance metrics such as confusion matrix, accuracy, precision, recall, specificity. Here we are achieved the AU score is 98.3%. This is the best score when compared with our existing system. After that we have to find mean value for all attributes from our data set and standard deviation values, and finally median values. Yeah, this is the first visualization graph for status, and this graph name is swamp plot. So this is our output part. This is the variable explorer. Variable explorer means which variables we are used in our process. That variables will be stored in this part. I already said data splitting, right? So this is the data splitting, and these are the variables, and it will display the type and also it display the size. So this is the output part. Okay, thank you.